You can respond to me in the chat. So our options are sine, cosine, and tangent. Good. Carol says privately, tangent. So here's our angle, right? So we're going to say tangent theta. Why did she pick tangent? And this, you guys probably learned this from Miss Probst, I would think. There's only, yeah, it's opposite over adjacent. Good. So tangent, TOA, opposite over adjacent, would be y over x. Okay. So there's our equation, right? And that's all there is to that one. So we're just looking for an equation that relates our variables. Here we have 3 variables, and the variables are theta, y, and x. And they're related by tangent because those are the sides that we had. So if y was the hypotenuse, we might use cosine of theta instead. So the equation depends on what we're given. Okay, now, before we move on, I'm going to make some notes about what it says in the text. So remember, in these problems, what we're looking for is a particular rate of change given whatever information we have already. So I'm going to read again one more time and annotate for numbers. So speed of 15 kilometers per hour, speed of 10 kilometers per hour, and then x and y, it tells us the distance between the ships. We already kind of got that from the picture. And then it says that x equals 4 kilometers, y equals 3 kilometers. And then I want to write down these two things. Okay. So I want to write down how fast x and y are changing. So dy dt, so the change in y is going to be what based on the text? There's only like 10 of us in here, so you can come off of mute to respond or answer me in the chat. Dy dt is the speed of ship. Which one, Brittany? Ship B. Good. So dy dt is ship B, and is going to be 10 kilometers per hour. Wait, did I do that wrong? Dy, yeah, I got that backwards because I wrote them in a dumb order. Yeah, dy dt is the speed of ship B, which is 10. Now dx dt is going to be negative 15. Why did I pick negative 15 here? Why did I pick negative 15? Yeah, good. So x is getting closer, right? Good. So this ship's moving this way. This ship is moving this way. So y is getting bigger. So it's positive derivative. X is getting smaller, so negative derivative. Good job, you guys. Okay. So this is all the information I know, right? We want to find the rate of change in radians per hour. Okay. So in our notation here, what are we trying to find? We want to find what? I guess I'll give you options. Yeah, the derivative of theta, we call it. So theta dt. Okay. So this is what we want to find. And the keyword is rate of change, right? You guys are good at finding that now. So because we're finding the rate of change, it means find the derivative. Okay. So here we go. We're going to take the derivative of both sides. So the derivative of tangent, you can look this one up on your formula sheet, secant squared, theta. And then chain rule, we're going to say d theta dt. Okay, and that should make us happy because we want what we're looking for to show up in our equation. Now, we have y over x on the right. So which derivatives rule do we need? For y over x. I think this is where some people got stuck. Remember, y is a function and x is a function. So we have a function divided by a function. Okay, one more time. The question is, how do we take the derivative of the right-hand side here? Yeah, good, Sophia. Quotient rule. So quotient rule would look like, remember, it is if we have f over g, quotient rule is the derivative of the bottom, so g times f prime, minus the top, or wait, yeah, minus the top times the derivative of the bottom, so f times g prime over g squared. Okay, so for this one, that would look like this. Okay, are there any questions on how I got that? I'm just following this model here. Okay. What's my next step? So I have an equation. I took the derivative of both sides. Yeah, we're going to start plugging stuff in. So let's see. My first variable is theta. And I don't think I know what theta is, right? So I'll skip that one for now. D theta dt is what I'm trying to find. So we don't know what that is yet. But x I have, dy dt I have, y I have, and dx dt I have. Okay, so we're going to plug in everything on the right-hand side. So that becomes, let's see, 4 times 10 minus 3 times negative 15. And watch your signs here. All over x squared. So x is 4. And we'll simplify the sum. So I get 40, 45 over 16. So 85 over 16 is equal to secant squared theta d theta dt. Okay. Now we're to the hard part. So we need to figure out what theta is, or we need to figure out what secant squared theta is. And this is where it's like a little bit different from the delta math ones. Where might we go here to figure out what secant squared is? Remember, secant of x is 1 over cosine of x. Do we know cosine is what? So cosine of an angle, SOHCAHTOA is what? What over what? How do you find the cosine of an angle? Okay, Kara, it's going to be x over what? This is where you had to be real smart. So cosine of an angle is adjacent over hypotenuse. Yeah, good, good, good. So we want x over the hypotenuse. Well, we know we have 4 and 3, right? What's my hypotenuse? Yeah. So we need to use Pythagorean theorem to figure out what that cosine is. Okay. So cosine of theta is adjacent over hypotenuse, which is 4 over 5. Okay. So that was the hard part for this one, is realizing you need to go back to the triangle and do a little bit of trig to find that missing value. Okay. So we're going to plug that in here. So cosine of theta we know is 4 over 5. So notice I never have to use like the trig buttons on my calculator for this one. Okay. So secant of theta is going to be the reciprocal of that, which is 5 over 4. And then I plug that in. So I get 5 over 4 squared d theta dt equals 85 over 16. And then I get 25 over 16 equals d theta dt equals 85 over 16. And then when I divide, you should get 17 over 5. Okay. Any questions on that one? It's pretty spicy. What should my units be, by the way? 17 over 5, it's a derivative. Good, Eric. Yeah, radians per hour. So we know it's a rate of change, so we should have something per something. And if you said, what, like 3.2? No, 3.4 radians per hour, that's fine as well. Okay. I'll post these notes somewhere and let you guys know where they are, okay, after class, in case you want to look at this. This one now, this one was tricky. I initially, I did this one and got it wrong, and Damien got it wrong for the same reason. So there is a particular trick to this one, and there's a spot where you can get hung up. So this one's like the wind chill is blah, 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 blah. The wind chill is given by this function, W of V. And then there's a whole bunch of stuff in here that we don't really care that much about. Like this doesn't really help us. This doesn't really help us. At time t equals 0, the wind velocity is v equals 20. And then the wind velocity increases at a constant rate of 5 miles per hour. Okay, so I can say dv dt is 5 miles per hour per hour. What is the rate of change of the wind chill with respect to time at t equals 3 hours? Okay, so we need to find the rate of change of the wind chill with respect to time. So dw is my wind chill, dt at t equals 3. And we know, this is why this one's tricky. At time t equals 0, wind velocity is 20. So I'm going to write that down this way. I'm going to say v of 0 is 20. And then we know this function, w of v. Okay. So notice I didn't just write down v equals 20, because v is changing over time. Right. So this says v is 20 at t equals 0. Let's see, I need dw dt, and I have w is given to me, so I'm going to take the derivative. Okay, and this one's just a power rule, right? So my constant goes away, and I'm going to do times 0.16 times this coefficient here. And I did that math ahead of time. You get 3.536. Oops. V to the negative 0.84. So this is a power rule derivative. And then chain rule, dv dt. Okay. So this one at first glance seems pretty easy, right? So I have the derivative, and I have this v of 0 equals 20, and then I have dv dt is 5. So I can plug this in right away. So times 5. Now what should I plug in for v? What should I plug in for v? So the reason that I got this wrong initially is I plugged in 20, but that's wrong. Because 20 goes with t equals 0, and we're looking for this t equals 3. Yeah, good call. 35. How did you get that? So v is a function of time. We know it starts at 20 and it's increasing at a constant rate of 5. So that's just a linear function. Yeah, good, Brittany. So we could write that down as this, 5t plus 20, right? And then v of 3 would be 35. Or as Brittany said in the chat, you can just add 5 3 times. So that was the trick to this one, is to plug in 35. Okay. So the trick to this one is that velocity is changing over time, and we have to use the correct time. So I think you get negative 0.892 degrees per hour. Okay. And I said give me 4 decimal places on these. And that's on purpose because on the AP exam, you need to have it right to 3 decimal places. So if you give them 4, there's no way you're going to get any rounding error there. Okay, so that's the solution to this one. And again, the trick is figuring this out here. Notice what I could have also done is I could have said that W, I could have taken that same function and plugged in V. So I could say that W is 55.6 minus 22.1 times 5t plus 20 to the point, what was it, 0.16. So I could have plugged in my velocity function in here, and I actually would have gotten the same result. Questions on this one? Do we agree that these are a little tougher than the delta math ones? Yeah. A little bit. So this is what we're building towards. I don't expect you guys to necessarily be here right away. As you look forward towards the quiz, the problems on the quiz are not all this challenging. Would you agree, Damien? Damien, you finished the quiz already? Quiz problems are a little bit easier than these problems were. Yeah. So like these problems that we just did, it was what we're building towards in the long term as we like look forward to the AP exam, but it's okay if we're not quite there yet. All right. And I should have predicted that that is going to be our entire time together. Like I said, I'm going to post these notes, probably just post them on the stream in Google Classroom later today if you want to look at them. But like, let me know if you have any particular questions. You can either like let me know right now in the chat, stick around after class, or email me, or whatever you need to do. I'm going to close the breakout rooms and bring everybody back. Okay, folks. So I got no calls for help today. Hopefully that means we were working along productively in our rooms. Remember, as I said earlier, we are aiming to complete